Well, we're going to talk about sum or difference of cubes. You may be, or hopefully are, familiar with uh, a difference of squares. That may be something that we've talked about before. A difference of squares is something that looks like this or has this form, a squared minus b squared, where this first term is some number or some term, some monomial squared, and then it's minus, and then this is some other term, some other monomial that's squared. So these are always subtraction, and both parts of them are something that's being squared. What we're talking about now is not squares, but cubes. And a cube is when you multiply a number by itself and then itself again. So things that would be cubes would be if we took 2 cubed and got 8. 8 would be a cube. Or 5 cubed is 125. 5 times 5 times 5. These are numbers that are cubes. If we have a variable in it, it could look like x cubed, because that's just x times x times x, or y cubed, or even, this is an interesting one, x to the 6th technically is a cube, and it's because this is a multiple of 3. It's a multiple of 3. As written as a cube, it would be this, x squared to the 3rd power. And you may be wondering, well, how in the world did he do that? This is the base, x squared, and this is the exponent. And if you remember from before, our exponent rules, you can multiply these two together to simplify and get it as x to the 6th. So x to the 6th is technically a cube, with x squared being the base. But what we're going to focus on are ones that are a little more straightforward than that. So what I'm going to do is I'm going to start with an example, and we are going to factor x to the 3rd minus 8. So the first thing we have to look at is, how many terms does this have? Two terms. And we want to look at both of those terms and say, are those things cubes? Well, x cubed is obviously a cube, and 8 is 2 to the 3rd power. So it is also a cube. And we have in the middle, our sign, our operation is subtraction. So this is a difference of cubes. Here is how we factor a difference of cubes. I'm going to write out the formula. A cubed minus b cubed is equal to, in parentheses, a minus b, close that parenthesis, so there's our first part, and then times, in a second parenthesis, a squared plus a b plus b squared, and then close that parenthesis. So let's analyze this for just a moment. This is the starting point, a cubed minus b cubed. A is the base of the first term. It's the thing being cubed. It's, in our example, it's the x. And so you look at this formula and you would replace all of these a's with an x. And then we look at the other term. We look at the b term. And in this example, b is 2. B is the thing being cubed to give us this 8. So in each of these cases, we would put a 2 where these b's are. And so when we factor it, it looks like this. X cubed minus 8 is equal to the quantity x minus 2, a minus b, x minus 2, times the quantity. Remember what a is? X, and it's going to be squared, plus, now here we have a times b. That's the x and the 2 multiplied together. Typically, we write the 2 first. Even though it says AB, we can write BA, 2x, plus, and then we take whatever the B was, which is 2, and we square it. Maybe that's easier for you to just do. Maybe you have to write it out like this first, and then square it. Or maybe you just write it as 4. And that's it. We're not able to factor this anymore. So this is our completely factored difference of cubes. Well, let's look at another one. Let's look at 27y cubed plus 1. So here's our next one. So pause and just look at this for a second and see if you can make sense of what this looks like. So does it fit into what we're looking at? Is it a sum or difference of cubes? Well, unlike the first problem, this one has an addition sign, right? So this is addition instead of subtraction. So this is a sum. 1 is obviously a perfect cube, or maybe not so obviously. It's 1 times 1 times 1. So this is 1 cubed. 1 is the base. But what about this thing? This is sort of messy. You might have to play with this a little bit. It has a number and it has a variable. Well, the y part of it is kind of easy. That's y cubed. But 27, do we know what the cube root of 27 is? What number times itself and times itself again is equal to 27? Hopefully you'll see that it's 3. So we can say that 3y is the base. And if we cube it, it's this thing that we started with. So let me show you how this one factors, because it's a little bit different than the first example. When we have a sum of cubes, a cubed plus b cubed, it looks like this. The quantity a plus b, so notice it's plus instead of minus, times the quantity a squared minus ab, so notice this one's minus instead of plus, and then plus b squared. So this looks very similar to the first one, except the placement of some plus and minus signs. So let's see what this is going to look like for this problem. I want to factor 27y cubed plus 1. I know that the a, the base, is 3y. So everywhere there's an a, highlight this, everywhere we see an a, go back to yellow, everywhere we see an a, we are going to replace that with the base 3y, the thing that was being cubed. And everywhere that we see a b, here, here, and here, we are going to replace that or substitute in a 1, because that was the base, 1 cubed. So let's do it. In fact, if you want to try and pause this and try it yourself first, go for it. I'm going to keep going. So the first binomial, a plus b, is 3y plus 1. 3y plus 1. This shows the a and the b. Times this trinomial. So this one you want to be a little careful with, because our base has a number and a variable. You might even want to write it out as 3y squared like that first. That might be helpful. Minus a times b, 3y times 1. It's not always going to be 1, so it's often helpful to write it as 3y times 1 like that. The a times the b in parentheses. That can be helpful. Plus b squared, 1 squared. That one's pretty simple. We know that's just going to be 1. But we do want to clean up this stuff, right? We want to simplify those two terms there as much as possible. So that'll look like this. The quantity 3y plus 1, which we have, times 3y squared is 9y squared. 3y quantity squared, I should say. You're squaring both the 3 and the y to get 9 times y squared. Minus 3y times 1 is 3y, and then plus 1. So there's our fully factored form for this sum of cubes. So notice how these are a little bit different. Just pay attention to where the signs are between when it's a difference and a sum. You add minus, plus, plus. Here you add plus, minus, plus. So you got to pay really close attention to which one of those it's going to be. Let's try one more. Here it's your job to try it. I'm going to just write the problem out, pause the video, and then try to see if you can factor this slightly more challenging one. 125 minus 27x cubed. So see if you can factor this based on what we talked about up here. I'll keep going. So we first have to identify if it's a sum or difference of cubes. Let's examine it. It's a difference because it's subtraction. And 125 is the same as 5 cubed. So it's 5 cubed. 5 is our base minus 27x cubed. It's kind of like the last one we did. This is the same as 3x quantity cubed. Okay? 3 times 3 times 3 is 27, and x times x times x is x cubed. So we group them together in one base in parentheses with that single exponent. So that is going to be equal to, so we remember how it goes. We have a cubed minus b cubed is quantity a minus b times the quantity a squared plus ab plus b squared. So that's going to look like this. 5 minus 3x, right? A minus b, this is a, this is b, times the quantity 5 squared. I'm just going to write it like this for now, and we'll clean it up. 5 squared, a squared, plus 5 times 3x, a times b, plus b squared, which is 3x quantity squared. Did you get all the things in the right place? 5 minus 3x, 5 squared, plus 5 times 3x, plus 3x quantity squared. Now let's clean it up. 5 minus 3x, that's the first parenthesis grouping, times the quantity 25 plus 15x plus 9x squared. It's okay that this is in an opposite order, that it's in ascending order, that the variable's at the end. That's totally fine because that's the form that it was given to us here. That's fine. So that is how we factor a sum or a difference of cubes.